Good afternoon. Thank you so much to Passive House Canada for including us in this amazing symposium. We're excited to share this conversation. Beth, Ilka, and I have been chatting for quite some time, and we thought interesting to share what all three of our companies are doing with integrated teams for better performing homes. So we're going to talk through each of our companies and our approaches, and then we're going to come back and have a little bit of a conversation amongst the three of us. So thanks for being here, and we'll see you in a second.
Hi, my name is Beth Campbell. I'm a project manager at Unity Homes in Keene, New Hampshire. And I want to talk a little bit about what we're doing at Unity and how we're working with the design, build, and the prefabrication process. Unity is a full design build company. We build panelized, high performance, residential, mainly residential projects. And within our company, we offer design, engineering, virtual fabrication, otherwise known as building out the 3D model, and panelized construction. All of that is done in-house. So we're a fully integrated company. Our factory produces wall and roof panels that are installed on site by crane. And we focus on the core assembly of the construction. So our panels are shipped with framing, sheathing, windows, doors, insulation, but not finishes. And we provide wall panels and roof panels for our projects. Here's an aerial view of our production facility. And as you can see, those white bundles in the foreground are projects ready to be shipped. They're shrink wrapped for weather protection, and they're ready to get loaded onto trucks. So we ship our panels around New England, and occasionally we will build projects beyond the New England region. And we always provide at least a partial raising crew. So we always assist with the raising, and oftentimes the local GC fills in the labor as needed on the build site. And typically we're working with a local GC who's prepping the site, pouring the concrete, and then doing the finishes once we have raised the shell of the building. And this is a pretty tidy site. You can see the crane is down. It looks like they've completed for the day. But projects can get dried in as little as 1 day, which is totally bonkers for those of us used to site-built construction. And of course, that depends on the site and the complexity of the build. This stage really is typically the most impressive stage for clients, the neighbors, and again, those of us used to site-built construction. I had a project go up recently here in Keene, New Hampshire. In 1 day, it was a very simple structure, 2-story rectangular box with a roof, and the neighbors left for work in the morning, and there was a concrete slab, and they came home at the end of the day, and there was a house with a roof, and they were freaking out. It was pretty fun. I wanted to be able to go over a little bit about our integrated design that really goes through the design to the engineering all the way through the site raising process, and mentioned that within our architectural system at Unity, we offer a few pre-designed core modules that you can then semi-customize. So what you're seeing here on the screen, for example, the blue area in this slide are different configurations that the client can choose for an optional first floor bedroom suite. So the core module is more of that purple, green, white, and then you can add on a bedroom suite, and then you have different pre-designed options for those. So there's a lot of what we call semi-customization that's available within our design system. And then thanks to this library that it really starts every design, it's our sales team that is able to handle the initial design work with the clients, as opposed to needing to go straight to the architects to be working with the clients. And this streamlines the process quite a bit. As you can imagine, with this type of integration, tools are really crucial for pulling off the project and making it successful. So in order to be able to hand off from sales to design to engineering, project management, procurement, and then later on to our virtual fabrication, we need some really excellent tools to help every stage of the process. And we love Miro. This is a screenshot from a Miro board of a recent project that I've been doing, which allows for what I call visual editing. The 2D drawings that are included on this Miro board are actually generated by our 3D model software. We use CADWork. And that means that from the beginning, we're working really from the 3D model, but we can pull the 2D drawings as we need for communication. And so as you can see by this number of comments, there's a lot of iteration, QC, and ideas generation that are facilitated by this type of visual editing format. And then lastly, I'd like to speak briefly about our virtual fabrication process. So once the project is ready, and most all of the details are figured out, the project, we always say the project gets built twice, once in virtual fabrication and then once for real. And virtual fabrication, for those of you that don't know, is the process of defining every stud, every fastener connection, and elaborating the model with all of those details. And for us, we typically go into the VFab process after the building permit is received and about 90% of the way through construction documents. Each department that we're working with internally has an extensive QC checklist that reviews the virtual build before we go into production. And then at this point, once this is prepared, our virtual model is prepared, it gets exported to our CNC equipment that we use. So our factories are fully automated. So that's all I'm going to say about that for now. We're going to be taking questions at the end of the presentation, and I would like to pass the presentation over to Edie Dillman with B.Public.
Thank you so much, Beth. I am Edie Dillman. I am CEO and co-founder of B.Public Prefab. We're a US-based offsite design and component company. We're women-owned and a public benefit corp designed to serve housing creation and environmental sustainability. So we launched products and services in January of 2020 with a pre-designed, pre-engineered kit of parts. So we have a standardized set of thermal structural envelope components for the construction of high performance building envelopes. So in our discussion today with this wonderful group of companies, we invested in the upfront design engineering details in order to empower many more architects, designers, contractors to build with, specify high performance and passive house performance across a wide range of projects. So we took the approach of the standard kit of parts and followed US light frame wood construction. So our assemblies, as you can see here in the slide, are fully wrapped in weather barrier on 5 sides. It includes the sheathing structure of both floor, roof, and wall panels. I think we've got 89 components currently. And then they're all fully insulated with dense packed cellulose. So we are addressing the embodied carbon of the materials we build with and shooting for that passive house performance of low energy for every project. We work across scale. So from small homes and studios up to 3 stories above parking and podium. We are geared for new construction residential, although we're doing some mixed use, and 1 to 3 stories. And working in the US, our primary markets right now are California, New Mexico, Colorado, and you can imagine across the US where code and mandates and energy conservation is a priority. Those are the markets we're working with. We do have a distributed manufacturing approach. So we're working with partners on contract manufacturing. And actually, we've got partners in Canada that produce panels for us and also do installs and travel to the US for that work. We're adding more capacity. We see more and more demand, both in single family and multifamily. So we are working on a pilot manufacturing shop here in New Mexico, which will also be used for training other manufacturers in our assemblies, as well as, importantly, and looking at the slide, the install crews, so that we have regional partners who are trained in the safety and the procedures of doing not only prefab, but that meticulous taping, sealing, and stitching of high performance buildings for long-term performance. This is just a quick slide on, we go very quickly from a concept dimensioned plan into a 3D model, and are able to estimate within a week project. And then we do flat pack. These are unfinished structural elements, and we do not supply windows and doors. We're agnostic to the manufacturers. However, we do have the details for install of 3-pane windows, as well as details on cladding attachments, foundation treatments, really trying to facilitate the quick design and implementation of high performance across project scales. This is a beautiful example of that envelope disappears behind the finishes selected and can really be flexible in approach and presentation. So it can fit into rural, urban, you name it. We're designed to do infill as well as off-grid construction. Here's just a great snapshot at all of the detail and data behind our components, the Flixo, the modeling, and this is our R values of that R value 35 and R52 for walls. Is coming out of the PHPP. So that data is provided to the certifiers and the consultants. We are not doing that work, but we will provide the data in order to run through certification. And then here's just a quick shot of our online tools that are available to all of you for downloading the SketchUp library to build components, or we will build your estimate model in these SketchUp models. And then we go deep dive into Revit in providing that final offsite set. Certainly we have a catalog of all of our shop drawings that are leveraged, as well as the ability to create custom shop drawings for those components that don't come straight out of our catalog. But again, the investment in the upfront engineering and utilization of a standard kit of parts to speed the adoption and help these integrated teams build with B.Public. And then just to land on this, we have spent time and effort in pre-designing high performance homes for developers as well as homeowner clients. So you can see this can be reskinned in many different treatments, and they can be stacked and utilized. But this has been a really great program, and we're happy to be helping some folks rebuilding from both the CZU fire in California, in Santa Cruz, and in the Marshall fire in Boulder, Colorado, taking these home plans and putting them to use for folks who need a rapid replacement of a home, but shooting for that high performance. So I'm going to pass the baton off to my friend Ilka Cassidy. And we'll see you after with discussion. Thanks so much.
Thank you, Edie. I'm also very excited to be presenting here alongside of you and Beth. And I'm also looking forward to some more Q&A at the end of this presentation. So I am Ilka Cassidy, and I'm the co-founder and principal of Holzraum System. At Holzraum System, we are a collection of some pretty unique backgrounds like software development and CNC programming and energy modeling, but we are mainly focused on passive house or high performance design and construction. And this is our home. We work in an office out of this beautiful building in Germantown, Philadelphia. Holzraum System is a thermal envelope design and consulting firm, and we develop and use foam-free, high-performance pre-manufactured panels. So this is our standard XP20. It's an airtight and vapor open assembly, which we actually also use as a hybrid combined with CLT panels. We engage during the architecture design phase and work closely with the architect and builder to translate their design intent into a parts-based model. Here we implement standard details that we have developed, but the panel size and build-up is typically specific to the project and location. And yeah, of course, we can develop prototypes for bigger home developments as well. And then we turn the parts-based model into files ready for offsite fabrication. So those outputs are also specific to the factory that we're working with. We are actually collaborating with several manufacturers, manufacturing facilities across North America. And we decide early on which manufacturer is the best fit for the project. So then what's interesting is that these outputs can also be geared towards site build support or local labor force who might want to build panels in a warehouse by hand without automation. Early on, when we started working with prefabrication, specifically using it in combination with passive house strategies, we saw the opportunity in adding more value to the parts-based model, which for fabrication, actually, this parts-based model has to be generated. So we realized that it can be used as a visual communication tool with endless data attached that includes all or a lot of other perspectives and helps coordinate them. So we always include load path, wood and steel, an MEP model, either supplied or generated, foundation, and then from there we can start clash detection between any numbers of perspectives and create a holistic single integrated manufacturing model. Since Beth, Edie, and I decided to talk about design integration, I wanted to explain our take on it. So for us, the SIM model becomes the core element that collects information into one, basically a hub from where it can actually get extracted once every perspective is aligned. So from this viewpoint, our workflow is very vertical, or it vertically integrates all team members. But the process itself is circular and iterative. And then in order to create easy access to all this information and data, we developed our Catch software. The key for us is to increase the effectiveness of the model by attaching as much data and information as it makes sense to the visualized parts. And then being able to use the same model for issue tracking and factory outputs. And this is how we do it. So we also use CADWork to create our parts-based holistic model. And we can identify a detail or a whole building section that we want to investigate closer. So all the parts and control layers are modeled, and we can rotate it, zoom in closer, turn parts off, look at and isolate, in this case, air sealing strategies. And then in order to make this model and the attached data accessible to all team members, we export an IFC file into our Holzraum Catch software. As I mentioned, one of our partners is a software developer, which is pretty helpful. So this IFC viewer contains exactly the geometry and attached data as the CAD work model. So now everyone can easily navigate, look at, and filter along properties, select and isolate parts. The IFC viewer is also connected to an issue tracker, which attaches comments to a specific view and can get called up anytime. So these issues, either attached to the viewer or not, become interactive with comments back and forth among all involved team members. So here we can see a list of the issues, and then we can type in a comment, and everyone who is involved in this process gets a notification. So this works the same on a whole building level and scale. It's pretty easy to navigate, and everyone can view attributes, filter, and turn parts on and off, depending on the perspective we are looking for. So this would be very interesting for a steel manufacturer, for example. So in this case, we are actually looking for the fasteners. We select them, and then we isolate them. Now all the data that is attached to what is visible on the screen can get downloaded into a CSV file and incorporated into pricing or ordering, or on-site kind of sequencing. Also part of Catch is file uploads, wiki pages, checklists, and we are actually working on connecting to Woofy for energy modeling and thermal bridge analysis. So yeah, this is basically what I wanted to share, and I'm looking forward to our discussion. Thank you.